right, welcome to Lecture 8. So in Lecture 8, there's going to be two parts. This part A, we're going to learn all about the periodic table. Man, the periodic table, we're going to be looking at it pretty much and using it all the time from here on. So in this lecture, we're going to talk about what it is and why it is helpful to us. And then in the second part B, we're going to talk about atoms versus ions. What's the difference and kind of how do we tell them apart? All right, so that'll be the second part. But with that, I think we're ready to go ahead and get started, and let's get going on the periodic table. What the heck is the periodic table, and why do we care? The periodic table was developed by this guy right here by the name of Dmitry Mendeleev. Dmitry Mendeleev. And actually, Dmitry Mendeleev, he actually didn't start off as a chemist. He started off as a biologist. And the kind of biology that he was interested in for most of his life, he was interested in taxonomy. So taxonomy is like in biology where they like group animals together, like based on like the way they look and behave, you know, like they put all the amphibians in one category and they put all the reptiles in another category and they put all the, I don't know, mammals in another category. So originally, that's kind of what he started doing. He originally was interested in like studying animals and seeing what they had in common, putting them into groups. That's taxonomy. Now, at one point in his life, he actually changed focus and he started to get more interested in chemistry. And he wanted to take that same idea about how can you group things together, and instead of doing it with animals and plants, group elements together. And that's exactly what the periodic table is. So the periodic table was developed by Mendeleev, and it actually was developed in 1869. So last year was the 150th anniversary of it. He developed it in 1869. And basically what the periodic table does is it groups similar elements together in vertical columns. Now these vertical columns even have like a name that kind of goes along with biology actually, because that's originally where he was coming from. He was a biologist. So in biology, if they say you are similar to another animal, they might say you're in the same family. So we sometimes say that in chemistry too. Elements that are similar to one another are in the same family. Sometimes we use the word group. So a group or a family, that is going up and down on the periodic table. So I'm going to show you a little example in a sec about what I mean by being similar. So being similar would mean that you look similar. It would mean that you have similar properties, that you do similar reactions, you behave similar, and so on. So for the example I'm about to show you, I'm going to take two elements that are in the same family, and I'm going to show you how they are similar to one another. Now, specifically, I'm going to do an example of how sodium, that's Na, is similar to potassium, which is K. Now, that would be true with anybody in this column. Lithium is going to be kind of similar, so would rubidium and cesium and all the rest of them in that first column. All right, so let me show you that example and with sodium and potassium. Let's get to that. All right, so I had to come outside because we're going to do a little demonstration. So one thing we just talked about is how sodium and potassium should be similar to one another because they're in the same column on the periodic table. So I brought my, who are you again?
Your wife.
Oh, that's right, my wife out just to make sure that I can use a little help here and not kill myself. So first off, sodium. What's the symbol for sodium?
I have no idea.
What do you teach again?
English.
That's that explains that
Yeah.
one. All right, Na and then K. Now again, if you look at the periodic table, they're right above each other. So I'm going to do a little demonstration, and we'll see that sodium and potassium are similar. So my wife is going to help run the camera and help me get this done here. So we just need to tip down. I have this beaker I'm going to show you, and hopefully you can zoom in on that a little bit. And so sodium and potassium, they're similar to one another. I know that because they're in the same column of the periodic table. So let me hold up. This is a piece of sodium. And wife, Robin, when you look at sodium, how would you describe it? What does it look like?
It is white, it is crystalline,
And it's really soft, actually. I could squeeze it. I just broke it in half, didn't I?
Okay.
All right, so it's kind of like a white, off-white color, really soft metal. Okay, so let's put it, I'm going to put it in this beaker of water, and we're going to see what happens. So let me go ahead and put it in. And what do you see happening?
I see bubbles coming up.
Bubbles, that's right. So it bubbles. So it's actually making hydrogen gas. So sodium reacts with water, and it's making hydrogen gas. There it goes. All right.
It's making a lot of hydrogen gas.
There you go. All right. So let's get the little piece that I broke off by accident. We'll throw it in there too. Wah! There we go. All right, now, the other thing that happened when I added the sodium, it made hydrogen. It also makes the water turn basic. Now, another word for basic is alkaline, and I can show you that because this strip, it's called litmus paper. If it's around something basic, or we could say alkaline, it should turn blue. So do you see how the water is now basic or alkaline? All right. So that's a little bit about how sodium behaves. Now I have one more chunk that fell off. Let me go ahead and dump it in just for the heck of it. And then we're going to move on to potassium. Now, English teacher wife of mine.
Yes.
What is the symbol for potassium?
I don't know.
You don't know. It's potassium is K. All right. So we're going to do the same thing with potassium. Again, right underneath where it is on the periodic table, right underneath sodium. So let me go ahead and get a little hunk of potassium out. And I don't want too big a piece, so let's go with, I might break this up a little bit. All right, and I'm going to show it to you on the camera in just a minute. But all right, so can you tell me, what does it look like?
It's a little purple, and it looks kind of squishy. Yeah,
so it's soft again, very soft. And it's almost like consistency of butter, actually. It was like if I touched it with my hands, it would feel like butter. All right, now let me show you. I'm going to put it in water again. And again, it's in the same column on the periodic table. So it should, oh, get off of there. It should do the same thing sodium did. Get off of there. Come on, you. Come on, you. Oh, stop. I'm going to get it. I got it. I'm a trained professional. All right. Nope. I'm a trained professional. All right. So oh, Lordy. All right. So why do you think that's happening? I told you it's making hydrogen, right? And what do you know about hydrogen?
It's a gas.
And it's flammable. All right. So it actually creates enough hydrogen, it kind of starts to react with the air. It makes a flame there. All right. Now, one last thing I want to show you was when we put sodium in water, it made the water what again?
It made it bubble.
And it made it what? Alkaline?
Making it alkaline, yeah.
There you go.
Yes,
work with me, wife.
Too.
All right. So same thing happens with potassium. So what we've learned, and what Mendeleev, the way he put together the periodic table is, if you're in the same column, which sodium and potassium are, you'll be similar to anything else in the same column. All right, let's move on. Hit stop.
Stop. Can I ask a stupid English teacher question? I don't know.
Okay, what's your stupid English teacher question?
Okay, sodium, how is what it does in water different from what I see table salt doing in water, which is just dissolving?
We'll get to that.
Okay.
All right, now I gotta hit stop. All right. What do we call these different parts of the periodic table, these different families? All right, so there's lots of them that we're gonna use the same term for over and over, so we better get familiar with them. So let's go through them. So first off, just in general, if you are an up and down thing, that is called a family or a group. So I could say, for example, that carbon and silicon are in the same family. Or I could say helium and neon and argon and krypton, all these guys are in the same family. So any vertical column is a family. Now, when we go across, going across, this is called a period, going across. So I could say that, for example, I don't know, silicon and phosphorus are in the same period, or oxygen and fluorine are in the same period. Periods are going across. Now, probably the more important ones are going up and down, right? Because if you're in the same up and down group, you're similar to anybody else in that up and down group. So these families have names. Now, let's go ahead and go through some of them that you need to be familiar with. So this column right here, so sometimes you're going to hear me call it the 1A column. Column 1A, if you're in column 1A, these guys are called the alkali metals. The alkali metals. Again, they're all going to be similar to one another. You saw that a minute ago. Sodium and potassium were similar. They're in the same column. They're both alkali metals. Now, if we go to the next column over, column 2A, usually I'm just going to call it 2A. You might just hear it called 2. So column 2A, that is going to be called the alkaline earth metals. And again, anybody in that column would be similar to anybody else in that column. Magnesium is similar to calcium, which is similar to strontium, barium, beryllium. They're all similar to one another. All right, now, what are a couple other families we talk a lot about? Well, a lot of them are actually on the far right side. Let's go way over to the right-hand side for a minute. This last column right here, I might call it column 8A, but most likely I'm going to say these guys are also known as the noble gases. They're all gases, so that sort of makes sense. Or we could call them the inert gases. So I'm talking about helium and neon and argon and krypton. They're all similar to one another. One way that they're similar is that they don't react. They're not dangerous or anything. They don't react very much. So that's sometimes why they're called inert. Inert means non-reactive, or noble. They don't do anything. So so that would be anybody in this column all the way down: helium, neon, argon, krypton, xenon, so on, radon. All right. Another column you should be familiar with is the one right next to it. Column 7A. 7A. That is called the Halogens Column. Again, all those things are going to be similar to one another. I'm talking about fluorine and chlorine and bromine, iodine, all the way down. All those are similar to one another. They're called the halogens. Now, as far as other parts of the periodic table, those are really the groups that are most important, but there are other parts that have names, okay? So let's go through those, a couple of those as well, a couple more. So one is going across. These bottom rows have names. These are called the actinides. So that actually is going across from element 90 to 103. And then the lanthanides are elements 58 all the way over to 71. Now, one thing that you might notice is actually, they actually are kind of in a little bit of an odd spot. It's kind of to make the periodic table easier to see. So you might notice the periodic table, it goes from, for example, it goes from, let's find it here, right here, 57, and then it jumps to 72. Well, the lanthanides are sort of really in between there. The reason why they're not drawn there is because then we have to make the periodic table super wide. So that we didn't want to do that because it wouldn't fit on a piece of paper. And similarly, you might notice that from 89, it skips to 104. So those actinides actually kind of fit in between there. All right. So a couple other areas I want you to be familiar with is you'll notice that there are columns, and above every column there is a name and then a letter. So sometimes the letter is the letter A, 8A, 7A, 6A, Roman numeral 6, 5A, 4A, 3A, and then over here, 2A and 1A. All of the A columns put together, they have a name. If you are an A column, so I'm talking about these fellas, and then these over here on the far right side, collectively, together, they're either called, I got to switch to my color here, sorry, the main group elements, or you might hear them called the representative elements, representative elements. Okay. All right, so those are all the A columns put together. Now, there's some columns, and they're actually kind of in the middle of the periodic table. They end with the letter B. So let me maybe do those in a different color. Here we go. Like 3B, 4B, 5B, 6B, all the way over here to 8B. Maybe I should be even a little more thorough. Let's shade them in. All this middle part right here, collectively, let me shade it in so you know what I'm talking about. You'll see above all those rows, they have the letter B, 5B, and so on. These are called the transition elements, or sometimes you hear them called the transition metals. We could say it either way, transition metals or transition elements. All right, So that's the middle section of the periodic table, that middle section. All right, last thing I want to point out again is you should be able to kind of, if I look at any column, you should be able to tell me a little bit about who else he's going to be similar to. So if I was to ask you about phosphorus, phosphorus is going to be similar to nitrogen. They're in the same column and so on. All right, so we divide up the periodic table, and this is one way. Different parts have different names. Now, I'm going to show you there is another way of dividing up the periodic table. Now, this periodic table already got pretty darn messy, maybe too messy. Sorry about that. But let me show you another way to divide up, and I'm going to go to a clean version of the periodic table so I can show you this way of dividing it up. So let's flip over to that right now. Okay, so you might have noticed that, yeah, I divide up the periodic table in all of these groups, but there's also another way of dividing up the periodic table, and you might have seen or noticed that there's this staircase-looking thing, huh? This staircase-looking thing, let me highlight it, go over it with red. That staircase-looking thing, sometimes you'll see it drawn all the way over, is another way of breaking up the periodic table. And it breaks up the periodic table into just two categories. Everything to the left is a metal of that staircase. Everything to the right is a nonmetal. All right. So if you are on the left-hand side of that staircase, I'm talking about all these elements, including the ones at the bottom, by the way. You're a metal. And then just these few in the top corner are nonmetals. All right. So what does that mean to be a metal or a nonmetal? We're going to get into that in just a minute. But what are there more of? Are there more metallic elements, metal elements, or more nonmetal elements? Which one are there more of? There's way more metal elements, right? All these guys right here are metals. All these guys right here are metals. And just these few in the top are nonmetals. All right, so let's take a minute and let's just talk about what do I mean by being a metal or being a nonmetal. So let's write a few notes about how these two categories are different. All right, let's get to that. All right, so metals. So metals are going to be elements that are shiny. Metals tend to be shiny. And I should tell you as I go down this list, yeah, there's exceptions, but generally speaking, metals are shiny. Metals tend to be good conductors. Yeah, there's exceptions, but mostly they're good conductors of heat and electricity. Heat and electricity. So your pots and pans in your house, they're made out of metals because you want the heat to get from the stove into your food, right? So you need something that carries heat really well. So pots and pans are made out of metals because we want that heat to transfer to our food really fast. What else can I tell you about metals? They tend to be solids. Now, again, there are some exceptions. There's only one real exception, mercury, but pretty much all the other metals are solids. And then a couple other things I want to tell you. So metals tend to also be malleable and ductile. So what the heck are those words? I never heard of those words before. Well, let me tell you. Malleable means that you can form it into a thin sheet. And then ductile, you can form them into a thin wire. All right. I'm going to say more about what I mean by that in just a minute, okay? So metals are shiny, they're good conductors, they're solids, they're malleable, they're ductile. Now, nonmetals, which are on the other side of the periodic table, on that top right corner, they're just basically the opposite of everything I just said. Instead of being shiny, they're the opposite of shiny. What's the opposite of shiny? Dull. Instead of being good conductors, they're bad conductors. They don't carry electricity very well. They don't carry heat very well. So they are bad conductors. Now, often instead of saying bad conductors, we have another word for that. They're called insulators. So if you hear like insulation, like you have insulation in your house, insulation means that the stuff on the wall, it keeps the heat inside your house when it's cold out or whatever, right? So you have insulation so that the heat doesn't move from in your house to out of the house or vice versa. All right. So what else? Oh, instead of being solids, what's the opposite of being a solid? Most of them, there are some exceptions. Most of them are liquids and gases. And then the opposite of being malleable and ductile, the opposite of that is being brittle. All right, so let me explain a little bit more about those terms. So I brought in I have a few examples here of, well, let's start off with the nonmetal. So one nonmetal, and I showed this to you before, this is sulfur, all right? So sulfur is this kind of yellowish rock. So it is a nonmetal. It's in the top right corner. I know it's a solid. I just said mostly they're liquids and gases, but mostly. So this is a solid nonmetal. Now, if I was to like mess with it, if I was to like hit it with a hammer, it would just splinter in a bunch of little pieces. In fact, I'm kind of just playing with it a little bit, and you can see it's really flaky. It kind of falls apart. So if I was to slam on it, it would just crack in a million little pieces, like some glass would, like glass would. If you do that though with a metal, it doesn't shatter in a million little pieces. If you hit it with a hammer, what'll happen to it is it'll stay together and it'll flatten out. So an example of a metal is actually aluminum. So I grabbed some aluminum foil from my house. So if we pound on a metal, it doesn't shatter, it doesn't break up, it just flattens out and turns into a thin sheet. So if I got a hammer, I could pound it and make it into a thin sheet. That's called being malleable. Now, same thing would be true for metals when you pull on them. When you pull on them, they'll turn into a long, thin wire. And somewhere around here, I had, right here, copper. So you could buy copper wire. So when you pull on it, it turns into a long, thin wire. Nonmetals don't do that. They just break apart. All right, so that's what I mean by brittle, that if you pull on them, they break up. If you hit them, they break up. They're brittle. Metals don't do that. You pull on them, they'll turn into a wire. You hit them with a hammer or something, they'll flatten out and you'll get a thin sheet, okay? So that's a little bit about the difference, okay? Now I should tell you there's actually one third category. Gotta blow that sulfur off my keyboard there. There's one last category, and that one last category are called semi-metals, or you might hear them called metalloids. Now, you know how we like to think everything's up, down, left, right, good, bad. That's not, that's not really how always the world works, right? There's always something in between. So, and that's what semi-metals are, or metalloids. They're not really going to be like a metal, and they're not going to be like a non-metal. They're going to be sort of in between. So, so let's write that down. They are, we'll say, have some properties like metals. Oh, I need more room. Well, sorry. And some like nonmetals, All right. So they have some of the properties of metals and some of the properties of nonmetals. They're in between. So what's an example of that? Well, an example of that is some things in the world are fantastic conductors, good conductors. Some things are terrible conductors, bad conductors. Some things in the world are kind of like okay at conducting. They conduct a little bit of electricity. So if you're okay, we call you a semiconductor. So a semiconductor, you'll find those in your cell phones or in your, I don't know, your computer right now contains a bunch of semiconductors. So semiconductors are materials that carry electricity but not very good. And they're used in electronics a lot. So like the most famous or most common example of a semiconductor is silicon. So if we go over to the periodic table, you're going to find silicon. It's right here. It's Si. Now, let me get to my highlighter there. There we go. It's Si. So, and in fact, you'll notice that it's right on that staircase I pointed out to you. And that's true for all the metalloids. So let's go over who's kind of in between. Well, I guess to go back just a step, you're over here, you're a metal. You're over here, you're a non-metal. So the breaking line, the dividing line is the red staircase. That divides the metals from the non-metals. But if you're on the line, you're kind of in between. So if you're on the line, you're going to be called a metalloid. Potentially, you could also hear the term semi-metal. So I am talking about silicon. You're a semi-metal. So is germanium arsenic, antimony, all the fellas on this staircase. All right, if you touch the line. Now, there's only one exception to that, and I did this on purpose. You notice I highlighted everything that touched the line except for one, and that is aluminum. Aluminum, I know it touches that red line, but it is actually considered a metal, even though it touches the line. All right, so that's our little brief introduction to the periodic table. Let's move on to our last part in this chapter 4. So we're still in chapter 4 of the Tro book. There's one more little topic I want you to be familiar with, and that'll be in part B of this video. Let's get to it.